So I want to start this video off by discussing the classic question, is math invented or discovered? Well, I believe that humans are very good at inventing things, and they can make a lot of discoveries because of those inventions. And the first invention in math is the number one. We live in a world of ones. Everything is one person, one tree, one animal, whatever you want to say. Everything is ones. We see them everywhere. Unfortunately, one isn't a real thing. What is one? I mean, you can say, well, you have one apple. Sorry for my drawings. Okay, that's our idea of one, but what if I take a bite out of it? Is it still one apple? What if I cut it in half? Is it still one apple, or is it two halves of an apple together make one? Okay, well, then you got to remember every number is based on the concept of one. So if we have two apples, are they equal? That means they have to be exactly the same. Well, one's if one's a lot smaller and one's a lot bigger. They're not equal. So they have to be the exact same weight. Okay, so we're going to go down to the atoms of the apples. Okay, say they have the same amount of apples. Well, they're going to be losing and gaining electrons and all that stuff all the time. They're going to radiate and all that. So maybe for a fraction of a moment they might be equal, but in general, they're not. And once again, we have things like geometry, right? We got our 3, 4, 5 triangle, and we go, wow, that's amazing that you have these whole numbers that create a triangle. But once again, we invented the 90-degree angle. That doesn't exist. I mean, we can get very good at approximating it and making it, but for the most part, it's not a real thing. So after we played around with ones and twos and threes for a while, we started noticing some strange things with math. And to me, they're not strange. They're actually more normal than all these ones and stuff that we actually had before. We found transcendental numbers like pi and e. And when you think about it long enough, these make total sense, because if you throw a dart at a infinite line, you have a 100% chance on landing on a transcendental number. There is nothing natural about natural numbers. Even things like the speed of light, it is not a rational number because we base our meter on it. We've made the meter so it fits. So yeah, if we started out using transcendental numbers and worked our way backwards, we'd have a completely different story right now. So yeah, all these discoveries we've made in math are based on an invention. But is there anything in the universe that we can discover? Well, ironically, there are two things, but we could never actually physically discover them. And that is zero and infinity. We could never see zero, and we can never see infinity. We can never get there. And the problem with how we see infinity is based on the fact that we started all of our math using one. And that's how we've ended up using these cardinals and countable infinities and all this stuff. Let's be honest, there's only one infinity, and that's infinity. And we can divide up infinity, and there'll be another infinity in there. You can divide it as much as you want. There's always going to be more infinities. But there's only one infinity. And if we started with this concept, we wouldn't be using cardinals and all that. We have a completely different language, and we would see the natural numbers in here as a subset of this larger infinity. So we as humans are very good at building up ideas on top of ideas and discoveries, right? But we can't really decide on what order that comes in. So it'd be like civilization, right? If we could start a brand new civilization with the knowledge that we have, there'd probably be windmills everywhere, and maybe cars wouldn't even exist. Do you know what I mean? We would learn from all the mistakes, but we don't seem to do that with anything, especially math. I mean, now we have infinity upon infinity upon infinities, you know, but this is all false. There's one infinity, and that's infinity. And the natural numbers, for instance, is a subset of that infinity. Okay, so if we started changing the language, maybe we'd have a much better understanding of all of this. So our concept of what's invented and what's discovered is completely flipped, right? We think that the ruler, we discovered the ruler, and we've placed it on the infinite number line, this concept of infinity, when it's the complete opposite. The infinite line exists, and we've created the ruler that goes on top of it. We have this same problem now with the universe, right? We have our universe, and now we're debating if there's a multiverse. Well, if there's a multiverse, now that's the universe, and our universe is now a subset or a sub-universe in the universe. You may say this is semantics, it's arguing over language, but that's just the way it is, right? You can't just keep building and building. You have to start with the biggest and then divide. So now we have the other thing that I believe we discovered. Well, we haven't actually discovered it, because once again, it's something that we can never discover, but we have an idea of what it is, and that is the concept of zero. And to me, this falls out of the idea of infinity. I like to use time as an example. If time is eternal, your lifespan is zero by comparison. Or if space is infinite, our planet, by comparison, has zero size. Now this goes into what I believe math really is, and that's just counting an infinite amount of zeros. I know that seems strange and stupid, but show me a 1, show me a 2. This is all we actually have, and we interpret these zeros as 1 to make sense of the world. This concept to me also explains how you can fit an infinite amount of things in a finite space, because it's all just zeros. If you watched my last video, I actually show that zeros are this and infinities are this. They're the same thing, just different sides of the coin. And this goes on forever. And it goes on forever, and no matter where you cut it off, it still has zero sides. And there's an infinite amount of these in every space. So where are all these zeros? Well, they're everywhere, right? Just like 0.999 is equal to 1, so is 1.0000 repeating. So when you say, what is 5 minus 4? Well, it's actually 5.00 repeating forever, 0.00. Now you can assume, sure, this is going to be 1, but you have to check an infinite amount of zeros to make sure with 100% certainty that it's 1. So for me, in conclusion, space and time are infinite. Maybe not our universe, but that doesn't mean time will stop because our universe ends. And the fact that everything is infinite means that everything is infinitely indivisible, or divisible, sorry. And all this math that we use, it works great for sure. But it's based on an invention that we made, and then we've made discoveries upon that. And that's why things like calculus uses infinity, right? And it's so accurate. Now I could go into why I believe this makes all the paradoxes, because we just don't accept this fact. I mean, and the weirdness of quantum mechanics and why it doesn't fit with general relativity. But maybe I'll do that in another video. But the bottom line is, life is an infinite amount of zeros. But we can only interact with it in ones. Thanks for watching.